Hello viewers, I am Kausalya. Today we are going to see the topic response of undamped second order system for unit step input. There are four types of system, basically depending upon the value of zeta. To have a clear idea, I had made a video already. I'll give the link in the description, you can see. Now we are going to discuss about undamped second order system. So what is the general representation of a second order system? So this is a general form of a second order system. C of S is your output and R of S is the input. For undamped case, there are four different types of second order system. In that, now we are discussing about undamped case. So for undamped case, the value of zeta is equal to 0. So when the value of zeta is equal to 0, just substitute the value in the above expression. When you substitute zeta equal to 0, this term reduces to 0 and here we will be having omega n square divided by s square plus omega n square. Right. And again for unit step input, when the type of input is unit step, what about the value of R of S? The R of S is equal to 1 by S. So here I am rearranging this expression. So C of S is equal to R of S into omega n square divided by S square plus omega n square. And the value of R of S is 1 by S. So just substitute the value of 1 by S here. And here you will be having 1 by S into omega n square by S square plus omega n square. So this is your value of C of S. The next step is by using partial fraction, we are going to find the solution for this expression. So here the denominator we are having two terms, right? So I am splitting and writing it using new two terms, that is A and B. A by S plus B by S square plus omega n square. Now take LCM. So when you take LCM, you will be having the denominator term will be S into S square plus omega n square. Right. So here when you cross multiply, you will be having A into S square plus omega n square plus B into S. Right. And here the left hand side as it is. So when you compare these two expressions, what happens? The denominator terms are equal. Right. We are having the same denominator terms. So as we are having same denominator terms, these two terms cancel each other. So here these two terms cancel each other and here we will be having omega n square equal to A into S square plus omega n square plus BS. Now we must find the values of A and B. So for finding the value of A, you see when you look closely, when you substitute the value of S equal to 0, this term reduces to 0 and we can easily find the value of A. So here just substitute S equal to 0. So when you substitute the value of S equal to 0, here you will be having the value of A is equal to 1. Right. And to find B, just substitute the value of J omega n. So here when you substitute J omega n, you see A into, in the place of S square, J omega n whole square plus omega n square plus B, and again in the place of S just substitute J omega n. So J omega n whole square. What is the value of J square? The value of J square is equal to minus 1. Right. So this becomes minus and omega n square becomes omega n the whole square. So here minus omega n square plus omega n square, this entire term reduces to 0. So remaining term is plus B J omega n. So omega n square is equal to B into J omega n and we need only B. So just move this term. This term when moved to this side becomes the denominator part. So omega n square by J into omega n, and omega n square and 1 omega n will get cancelled and the remaining term is omega n by J. When you move this J term to the numerator part, this plus J becomes minus J omega n. So what is your J omega n? J omega n is nothing but your S. So here substitute minus in the place of J omega n, just substitute the value of S. Right. Now we know the values of A and B. we have to substitute these two values in our expression, this expression number 1. Right. So this is your equation or expression number 1. So just substitute the values of A and D. So when you substitute the values, here C of S is equal to A by S plus B by S square plus omega n square. So just substitute the values. When you substitute the value, we are having this equation. And again, we are studying time response analysis. So we need to take inverse Laplace transform. So when you take inverse Laplace transform on both the sides, then we will be having inverse Laplace of C of S is equal to inverse Laplace of this expression. So Laplace in inverse Laplace of C of S is C of t, which is equal to 1. That is 1 by S. When you take inverse Laplace, that becomes 1. And when you take inverse Laplace for this expression, that becomes cos omega nt. This is your final output expression. So when you draw the graph for this expression, the output graph is like this. Okay, we are having output graph like this. So here the response is said to be completely oscillatory. So what is meant by completely oscillatory? This system never reaches a steady state or stable state, and this system output will be continuously varying. That is known as completely oscillatory. If we never want a system like this, because we will always want a system that gives a steady input or a that gives a steady output or a precise output. So here the response is completely oscillatory, and again this type of system does not exist in practice, because whatever may be the type of system, it will be having some amount of damping ratio. But when the value of damping ratio is 0, then there is no use with that system, and that too, that type of system is not practically possible. Hope you people understand the video. Thank you.